Assalamu alaikum. How are you, my dear students? I welcome you all into my today class. Today class is the about the rectification, rectifier, half wave rectification, and full wave rectification. So let us start with the name of Allah Almighty. So the first rectification. That what is rectification? Rectification. Rectification. Rectification, it is the process of it is the process of the process of converting it is the process of converting alternating current, yeah, AC into DC is called the process of converting AC into DC is called rectification, while the device which it does so is called rectifier. The device is called what? The device is called the device is called the rectifier. Rectifier. The device is called what? The device is called the rectifier. Now, what does this consist of, the rectifier itself? The rectifier consists of one or more diode, one or more diodes, PN junction diode, okay, diodes used, one or more diode used for the conversion of, for the conversion of AC into DC. This is the rectifier. This is what? This is the rectifier. Now let's see, as I told, that one or more diode used, one or more diode. Now the when we use one diode for the conversion of this, then when one diode is used, then we have the kind of rectifier known as the half wave rectifier. The half wave rectifier. The half wave rectifier. The half wave rectifier is the kind of rectifier which uses one diode only. One diode only. One diode only. And this kind of rectifier allow the positive half cycle to pass through. I will explain this inshallah right now. Allow the positive half cycle of the AC, half cycle of the AC, allow the positive half cycle of the AC, allow the positive half cycle of the AC to pass through, while block while block the negative half cycle, the negative half cycle, while it blocks the negative half cycle. So only means that the positive half cycle is rectified. Positive half cycle is rectified, while the negative half cycle is blocked. This is known as the half wave rectification. Yeah, the half wave rectifier. Contrary to this, we have the full wave rectification. We have the full wave rectifier or full wave rectification. In the full wave rectification, this uses the full wave rectifier use more than two diodes, more than one diode. It can be two diode or more than one diode. More than what? Uses more than one diode. As you see here, look, we use more than one diode. Here you see the four diode. This is known as the example of such diode is called the bridge rectifier. The bridge rectifier. Called what? The bridge rectifier. That is called which rectifier? That is called the bridge rectifier. We call it which rectifier? We call it the bridge rectifier. Okay. Sorry for that, here the spelling is wrong. So that is called the bridge rectifier. There could be a full wave rectifier which consists of two diodes also. Okay, so that is the as let me tell you one important thing here again. The rectifier, what does it actually do? The rectifiers allow the current allow the current to flow allow the current to flow in one direction only, in one direction only. It allow to flow the current in one direction only. So here there is the in the case of the full wave rectification, both the positive and the negative half cycle, both the positive and the negative half cycle of the AC waveform is rectified. There. Now then the uses of the diodes, and I will tell you in brief about the uses of the half and the full wave rectifiers. But let us first see that how the diode consists of. Now let us see in this diagram. Here you see that a simple can of diode. I'm explaining to you the half wave rectifier. Okay, so in the case of the half wave rectifier, here you see that it consists of a diode. You see the electronic symbol of the diode here with its this anode and with its this is sorry the this is the P side, the anode of the diode, while this is the cathode of the diode. Here we see that we have this arrangement which you see. This is known as the center tape transformer. Center tape transformer, as you see here. Now let me choose. Okay, I will do with this one. Here, this is our input supply. This is our what? This is our input. Here now you see that we have the resistor also in our circuit. Now, what does this resistor actually do? That it control the current, allow a steady current to pass through. Here we have the output, as you see. This is our output. Now let us see that the input, we have the input AC signal, and we have the rectified, we have here the rectified AC signal, Now let us see that if this is the, let me label it like this is, as you see, time, and you see here we have the potential difference. We, this purpose of the step up transformer is to uh, to change the that is to step down the AC voltage source, because there is one important point which I want to share with you, that this diode has one drawback, right? And it is what? Heat sensitive. Heat sensitive, right? Therefore, there must be a limited current that would pass through this diode, and this is why we have to keep it safe. We have a resistor which only allow a constant flow of current through the diode, and first we drop the potential difference also. Here now look and see, this is one time period of the diode here. This is 2t, and this is half t, and that is then t by 4 and 3t by 4, and we have nothing to do with it because that is not our part here. Now look at the first place, when right now here, when there arrives, for example, look, I just want to first, let me describe this as the point A of the diode, sorry, the resistance, and this is the point B. Now look, that is during the positive half cycle of the diode, here you see, look, first let me just make this thing so that you can see. Now, during the positive half cycle of the diode, during positive half cycle of the diode, as you see, during the positive half cycle, during the positive half cycle of the AC waveform, AC waveform, what is going to happen here? Now, what is the positive half cycle? The positive half cycle is from 0 to t by 2. That is, what will happen during the positive half cycle, as you see here, look, they, at the anode of the diode acts like as it is connected with the positive terminal, and then look, this will become positive, and then this will becomes negative. It comes as it is connected with the negative terminal of the battery. During this situation, the diode acts in the forward biased situation, right? And it will conduct current, and it have a very small resistance, and it will allow the electricity to pass through, as you see here. Look, that is the positive half cycle of the diode is conducted, as you see, look in this diagram. So the positive half cycle is allowed to pass through, and here I would mark it like this, that if I just label the current with a green, so the current pass from the resistor in this direction from A to B, okay, this being positive and this being negative. Now during the negative half cycle of the diode, now let us see that what is going in the negative half cycle of the diode. When there is the negative half cycle, let us do it with a different color pencil. For example, let's say with this one. During the negative half cycle, as you see, this is the negative half cycle. What does this means? That in the negative half cycle, that is from t by 2, that is here I will write from, look, from t to t by 2 to t, this is the negative half cycle. And what will happen, this will now become negative, right? And then this is become positive in the negative half cycle, because in the positive half cycle the current was flowing in this direction. In the negative half cycle, that is better I would write it here so that you have a better understanding. In the negative half cycle, from in the negative half cycle from t by 2 to t, this is the negative half cycle. the current begins to flow in this way. So in the negative half cycle, this will become positive indeed. And the other end, this end will become positive, and definitely this end will become negative. So here you see that it seems as the anode of the diode is connected with the negative terminal of the battery, and the inside of the diode is connected, the cathode, with the positive terminal of the battery. In this case, the diode will act in the reverse biased situation, contrary to the one in which it was acting in the forward bias situation. So in this case, the diode does not conduct, and it wouldn't allow the current to pass through. And what you see here, during that period, during that period, here you see that no current is conducted, right? So what does this mean? That it does not allow the current to flow from B to A in this situation. So the diode does not conduct. Again now, that is, this is just in one half cycle of the AC. Again from T2, again, like for example, when it repeated cycle, the same thing will happen again and again. So you here you see that the positive half cycle is that the positive half cycle is allowed, positive half cycle is allowed to pass through, while the negative half cycle is rectified, it is blocked. The negative half cycle is blocked, as you see. So here you only see that the current flows in the direction of from A to B only through the resistor, and it is blocked from B to A. Clear? So this is for the half rectification only. Now let us see that in the that what is going to happen in the full wave rectification. In the full wave rectification, it consists of two diode bridged together. Here you see, look at this arrangement, a kind of diamond arrangement. Here you see that you have the diode D1, the diode D2, D3, and D4. This just seem like our Wheatstone bridge circuit. The two diodes, that is a combination of series and parallel combination of the diode, two diode in series, and then the pair of the diodes in the parallel here. Now look that how does it acts, right? That is, here both the positive half cycle and the negative half cycle are allowed to pass through. And let me explain this to you. This is, look, it all happens in this way, as you see here. Now look here, that what is going to happen here. Again, this is the load resistance. I will mark this as A, and I will mark this as B. Now this, you see that this is the anode and this is the cathode, anode and cathode, anode and cathode of the diode. Now look, you have the diode D1, D2, D3, and D4. Now let us see, let me explain it to you. During the positive half cycle, that is that what happens at this point during the positive half cycle. This is the positive half cycle. This is let me do it. This is 0, this is T, this is T by 2. So the positive half cycle, the positive half cycle, that is always here from 0 to T by 2. So during the positive half cycle, as you see here, look what happens here. At the positive half cycle, when the current appear like this one, for example, the positive half cycle here. So for the positive half cycle, diode D2 conducts, while D1 block the flow of current, it goes into the reverse bias condition, while this goes into the forward bias condition. And here let me mark it like this for the positive half cycle, as you see, like this one. Look, so this does not conduct while this conduct here. And now look what is going to happen. As you see, the current pass from what, that is the direction of the current, as you see, like this one, right? Look, that the current pass through this one during the positive half cycle and return back. Clear? So you see that during the positive half cycle, the current pass from A to B. The positive half cycle is allowed to pass through while the negative half cycle is blocked. Now let us see during the negative half cycle. During what happens during the negative half cycle? From T by 2 to T. This is what the negative half cycle. Now let us see that what happens during the negative half cycle. In the negative half cycle, this time that is what happens, they become as the neutral terminal and this as the positive terminal. And what is going to happen for the current? Let us see here. During the negative half cycle, the reverse happens. This acts as a positive and that acts as a negative, just contrary to this, the pink one. Now, when it acts as a positive, right here as you see, and now look, let us see for the negative half cycle. Look, the current is then flowing here. Now, look what is going to happen. Now, the diode D3 does not conduct while D4 conduct. It allows the flow of the current. And now you see, look what happens. This conduct, but here the current cannot flow that way, it doesn't conduct. And here what you see, look, very interesting thing is going to happen here. Again the current is flowing from A to B and like this, as you see it, look, like this one. And now what is going to happen here, that one does not conduct and it conduct, like sorry, that like this one, and it safely return. Okay, so here every time you see that in the negative half cycle the current again passed from A to B, and this time you see that the negative half cycle is also allowed to pass through. The negative half cycle is also allowed, what the negative half cycle is also the negative half cycle is also allowed to pass through. Is it clear? So both the positive and the negative half cycle is rectified here. So this is known as the full wave rectification, which can be carried out by using the bridge rectifier, which consists on four diodes only. Now we have the some uses of the half wave rectification, half wave rectifier. Here we have the half wave rectifier and here we have the full wave rectifier, the full wave rectifier. And I would like to tell you few uses of both of these. That is the it is used in the charging circuit, usually low power, used in what, in the charging circuit. In this charging circuit, usually the low power charging circuit. Okay, it is used in the pulse generator. Pulse generator, for example, if you want to generate electric pulse, like when you touch the remote controller, the button of your remote control to build up volume or to change channel, like that, that is called pulse generating. So it is used in a pulse generating. It is also used in the signal demodulation. Demodulation. Signal demodulation is separating carrier waves from the source waves, right? That is known as demodulation, right? That is, for example, removing audio waves from the carrier waves, right? In a television, or removing video waves from the carrier waves in a television set. That is known as the demodulation. Or, for example, I would like to give you the example like AM modulation, amplitude modulation, right? So it is used in the modulation process, right? Similarly, contrary to this, that is used the full wave rectifier, for example, for the battery charging circuits. So this is large scale for battery charging for battery charging circuits. For battery charging circuit, this could be also used in the high power applications. High power applications where high power is required, right? So this full wave rectifier is used in your mobile phone, laptop charging, or the LCDs, LEDs. They can be used there also, right? They Another example is, for example, it can be used in the home inverters, right? They can be used in the home inverters, for example, to convert the AC into DC. So these are the few applications of the diode. There could be many, almost every electrical appliance, electronic appliance contain diode in one way or the other. So this is our today topic about the diode. So inshallah, in the next lecture I will explain to you about transistor. Okay, so thank you very much for being